If you want to build your own do-it-yourself motion controller, you can still make use of the PureMoCo firmware and app. In the Google Play Store you will find a demo version of the PureMoCo app. This version is limited to only one stepper and only manual mode is available. If you want to make use of all other functions, you can purchase the full version of the app. There are 3 different ways to build up a motion controller. For basic setup and testing, I would recommend using a breadboard. This enables you a very quick setup, since you don't have to make any solder connections. But since the connections are only plugged in, they might become loose if you transport the system, so it is not very suitable for using outside. The other solution would be to use a perfboard. This has already the holes with the right distance for most components. In this case, you have to solder all connections. This might take some time, but this solution is much more robust than the breadboard solution. The best solution would be to order a custom-made PureMoCo circuit board. You can purchase this board as an assembly kit which contains all other components which are necessary, including a custom-made housing for the whole controller. If you only want to use 2 axes, you can also choose the PureMoCo mini controller. It has almost the same functions and features like the big controller. But you are not able to use the PlayStation 4 controller option, and there's no voltage regulator to power your camera. Those features are only available with the big controller, which is able to control up to 6 steppers. In this video I will explain how to set up a controller based on a breadboard. Here you can see the main components which are necessary to get the basic function to move a stepper over the Android app. The controller offers some more functions which will not be explained now. A full documentation will be available later. At first, let me explain you the general setup of a breadboard. On most breadboards you will find red and blue lines, which are meant to be used for the general voltage and ground connection. In this case, I have 2 separate lines left and right. All pins along the red line are connected together. Same for the blue line. We will use one red line for the 3.3 volt and one blue line for the ground connection. In the middle you will find 2 columns. If you have a closer look at the picture, you will see that all 5 pins next to each other are connected together. So it does not matter which of the 5 pins we are using, since all are connected together. Let's start by explaining the components. The main component is the Teensy 3.6. This is a microcontroller board which is 100% compatible with the Arduino software and setup. The main advantage of the Teensy 3.6 is that it is much smaller compared to a standard Arduino, and it offers more processing power than the most powerful the Arduino Duo. For the communication with the Android app, a Bluetooth 4.0 connection is used. One simple and cheap model is the HM10, which can be found on eBay for example. Make sure that you purchase the version which has already the pins attached. To connect and control the stepper motors, we need stepper drivers. In this example, we are using the SilentStepStick TMC 2100 since the connection and setup is very easy. But I would recommend using the TMC 2130 since it offers more functions and configuration possibilities. The price is almost identical. With the PureMoCo app, up to 6 stepper motors can be controlled. In most cases, you will have a 12 volt battery to power the whole controller. The Teensy only supports an input voltage of 6 volts, so you need a voltage converter. I am using the LM2596, which can also be found on eBay. This converter must be set to 5 volt, since other components will need 5 volt. The converter has 4 connection pads, 2 for input and 2 for output. With the potentiometer screw, you are able to adjust the voltage to 5 volt. When you connect your Teensy to your computer, you always should make sure that you have disconnected the input voltage. Just to be sure to get no damage on your computer, please cut this connection like recommended from the Teensy manufacturer. At first, we connect a 5V output and ground signal from the voltage converter to the Teensy. Then we connect a 3.3V output from the Teensy to the red breadboard line, so that we have 3.3V along the complete line. We also connect a ground signal from the Teensy to the blue line. The Teensy is now connected and we can continue with the Bluetooth module. We connect the VCC to the red line, since this is our 3.3V source. The ground signal will be connected to the blue line. The TXD on the Bluetooth module belongs to pin 34 and the RXD to pin 33. Here you can see the connection layout for the SilentStepStick TMC 2100. Please pay attention to the orientation of the driver. This side has to face up, so the chip must be on the bottom side. Otherwise, you will not be able to reach the current adjustment screw. In the upper left corner, you have the connections for the input voltage and ground signal for the driver. We are using a Teensy, so the complete board has a 3.3V limit. If you connect 5V to those pins, you will damage the Teensy board. Below that, you find the 4 pins to connect your stepper. And at the lower left corner, you have the connections for the input voltage, which is 12V in most cases. In this chart, the motor supply voltage is specified with up to 45V. If you have paid attention earlier, you might can remember that our voltage regulator has only an input voltage of maximum 35V. So always pay attention to the maximum voltage if you are not using 12V. A higher voltage will result in more torque and power of the stepper motor, but the steppers and drivers will get really hot and maybe shut down due to the high temperature. I would recommend using only 12V, which is a good balance between torque and temperature for most steppers. On the right side of the driver, you will find the input connections for the step and direction signal from the Teensy. You are also able to connect the enable and config pins to be able to control the microstepping and switch on and off the stepper motors. If the enable pin is left open, the stepper will be automatically enabled as soon as the supply voltage is connected. This all is described in detail on the SilentStepStick Github page, so I will skip that part. In the lower left corner of the driver, you will also find the tiny set screw to adjust the maximum stepper current. The driver will provide a maximum current of 1.2 A, but in most cases 0.6 A will also do the job. This is depending a lot on the stepper design and must be tested individually. A high current will result in more torque and you will be able to reach higher speeds with the stepper, but the power consumption will also increase. With higher current, you will also notice that the driver and stepper will heat up. This energy is lost, which is bad if you are using a battery as power source. So you want to set the current as low as your application and stepper allows it. 12 volt input voltage and 0.6 current limit is the standard configuration which should work for the most stepper motors. The current will be adjusted by turning the set screw. Then you need to measure the voltage between the VREF pin and ground. The whole process will be described in another video. So this is how the connection looks like in our example. The pins for the step and direction input are for the x-axis. This is the only axis which is supported with the demo version of the app. The pin layout of the complete Teensy can be found in the documentation, which will be published later on the website. Please make sure that you connect the stepper wires the correct way. For this, please have a look into the datasheet of your stepper. There you will find which wire color belongs where. So we start by connecting the ground signal of the driver to the blue line of the breadboard. The 3.3 volt supply will be connected to the red line. The direction input is connected to pin 2 and the step input to pin 3. Then we connect the stepper motor. In this case, I have used green wires for one coil and orange wires for the other coil. If you switch both green or both orange wires, you will change the direction of the stepper movement. The last connection which we need to make is the voltage input for the stepper drivers. The controller is now finished. We just need to upload the latest firmware to the Teensy before we can start testing. Now we can power up the controller and start the Android app. As you can see, everything is working and our do-it-yourself motion controller is finished. Do not forget to adjust the maximum current of the stepper drivers.